Yo, what's up? It is me, and I'm going to go over the Jupyter notebooks that I have that I'm using to make predictions on player props. So I have a little repo that I made. It's public, so you guys can just go to my GitHub and get it. No need to get any permissions. The README isn't really necessary. But I just wanted to go over kind of just like how the notebook works because it's a little disorganized and confusing if you aren't really sure what to do, because you have to put in numbers correctly. I know I'm going to go over and show you guys that, but you can go here and you can get the notebook. But I have the notebook running already, but this is what you'll see when you come to the repo. So let's get into it. So I already have the Jupyter notebooks running locally. So, and if you don't know how to set that up, you can just look that up online. I'm not going to go over that because that's pretty straightforward and easy. But I do have a requirements file in the GitHub, so you can install the correct requirements when you make your virtual environment. But here's the notebook. Not everything you see here is in the GitHub repo, but ignore team data. That's something I made years ago. But what we're going to focus on is this one here. I already have it running up here. And then this is just player data. And this is data that I don't have in the repo. But this is stuff that you can get exactly from using the Scrapy bot that I have also on my GitHub. Where is it? Here we go. So you guys can go get that here. The README is actually pretty good. Actually, like, makes sense if you follow it. So you can go get the code to scrape data from Sports Reference. But let's go back to the disorganized model. But here's what the player data will look like. So you can take a look at that in your own time after you scrape it. But let's take a look at the model. So the model is inside of notebooks, player model. So I already kind of ran some of this stuff, but you want to import, of course, pandas and numpy, because that's what we're going to be using to take a look at the data and then just run some basic stats. So we're going to use this Anfree Simons. Spelled his first name wrong, but that's what doesn't matter. I'll put that in a PD. And here's the data that we were just looking at previously in the CSV. You could ignore this because we don't need to calculate home and away. I already have that done in the bot, the scraper. It serializes it, so that's already taken care of. Yeah, ignore this too. This, honestly, I could delete these two cells, doesn't matter. But let's calculate his rest, because that hasn't been done, and we want to know how many days off he's had between games. This is just more visualization. His last 5 games. This data is not up to date because he played a game last night, but here's the previous games up until yesterday, the 4th. Describe, that's just a NumPy method that just kind of gives you a bunch of basic statistics that you can find on ESPN or sportsreference.com, so not really necessary to have. Same thing here, how many points he scores home and away, the median, which is how sportsbooks usually determine the over-under on points or any kind of player prop. His player prop last night was 18.5. He's been, some had it at 19, I think, 19.5, but he's been playing pretty poorly, so I've been tracking that and been wanting to take his under. So this is where we get into the fun stuff. Here's the model. So what we're doing here is we're saying, hey, y is what we are going to try and predict. We want to predict points. And then feature names are the pieces of data we are going to say, this is what you're going to take, and based off that information, you will make a prediction on how many points the player will score. So we're doing rest, field goals attempted, total rebounds, and threes attempts. And then we're just going to put that into this X variable, and then we'll obviously import scikit-learn to then split up the data and then train and place it in these 4 variables. Keep in mind, I got almost all of this code from the Kaggle model tutorial, and I highly recommend you check that out because it is very helpful, and most of this code is straight from that. I did not come up with all this on my own. Same here, this just gets the mean average error, which just helps us understand how poorly or how well the model is doing. You want a low mean average error. So here's going to cycle through just how many nodes we want to put in our random forest regression model thing. So it'll just let us know, like, hey, like the mean average for this 5 was this number, and then for 25 it was this number. It's kind of, I don't really understand it, but I don't know. It's from the Kaggle tutorial. So it'll just kind of tell you how poorly or how well the model did based off the nodes. And then the best one was 25, which you could do 50 or 100. I don't know. It doesn't really matter. This is another piece of code that I stole from somewhere that will do the same thing. Tells you just, hey, this is the mean average. This is also something that I got from, not the Kaggle tutorial, but I think I got it from ChatGPT. And this one will tell you what the max depth should be, so 10. So we already have that set here, so okay, don't worry about that. Okay, so here I already kind of printed it out, but this will show you how well the model did when it actually did make real predictions after we trained it. So you can kind of see, okay, did pretty well on some, like predicted 24, he scored 25, but obviously terrible on some, like model thought he'd score 13, he scored 21. So that kind of shows you, like, this isn't really that great. Here's a visualization in a graph form of the data that we just printed out here in graph. So you can see this is the predicted numbers, and this is the actual. So yeah, you can just kind of tell, like, okay, if it's like fairly square or even, like the model did well, but like this is obviously like a horrible prediction. So it's not really that good, but you know, I wouldn't just follow this model blindly. You gotta take a look at how they've been playing and stuff. So this is the actual fun stuff. This is where we'll actually make the real prediction. So this is where we're going to say, okay, for future events, we are going to plug in these numbers, which are the numbers that we are making the predictions on: rest, field goal, total rebounds, and 3 points attempted. And then the model will say, hey, based off these numbers you gave me, he will score X points. And so to get these numbers, you want to get some kind of simulator that also has made projections, and you can find these all over the internet. Some are paid, some are free. I've been using Sportslines because it's free, and I think they've got something that's fairly decent. So this is kind of what it looks like. I usually just search Sportsline NBA projection simulation. They have it here, and so they project a lot of things. They'll do assists, rebounds, almost all of it. So I'll get their field goals attempted data and their total rebounds. So I don't even really have to worry about, like, oh, like what should I plug in for the estimated or for the model. So I just put in these numbers here. So I said, okay, he's going off 2 days rest. He'll attempt 12 field goals. He will get 4.7 rebounds, and he'll attempt 6 3-pointers. And the model will print out a number, which is the number we already saw, and the model says he will score 12 points. I don't know if this is the exact data I entered in yesterday, but the model said he would score 13, and he scored exactly 13 yesterday. So kind of cool when it works. That happened the same time with Paulo. Model said he'd score 21. He scored exactly 21. So it has its moments, but it's obviously not foolproof. It said Steph Curry would score 19 points last night. Steph Curry scored 24. So I wouldn't follow it blindly, but it can work. Hope it helps.